Hello students, in this part we will be discussing the next two types, which are the conversion of product to sum form and sum to product form. So let's start. Let's start with the next type of questions that can be framed by solving the equations. So the type of question is by solving equations by transforming the sum of trigonometric functions into product form. That is, a sum of trigonometric functions would be given to me and I can convert it in product form to simplify my trigonometric equation and then get the solutions to it. So I'll take an example then. The general solution for sin x plus sin 5x is equal to sin 2x plus sin 4x. Let's have a general solution for that. On the left hand side I have sin c plus sin d, so that will give me 2 sin c plus d by 2, that is 3x, cos of c minus d by 2, that is 5 minus 1 would be 4, so cos 2x. On the right hand side I will have 2 cos 2 sin 3x cos of x. 2 would cancel out and I will get sin of 3x cos of 2x minus sin 3x into cos of x is equal to 0 by transposing. Now sin 3x will be taken common, which would leave behind cos of 2x minus cos of x is equal to 0. So one of the factors has to be equal to 0, so either sin 3x is 0 or cos 2x is equal to cos of x. If sin 3x is equal to 0, then what we will have is 3x is equal to n pi or x is equal to n pi by 3, whereas if I have cos 2x is equal to cos of x, I will have 2x is equal to 2n pi plus minus of x. I will have variables on both the sides. Now for the two signs that I have plus and minus, I will solve and get two more solutions other than n pi by 3. So for positive I will have x is equal to 2n pi, and for negative I will have 2n pi by 3. So the three general solution forms that I have that would satisfy the equation is one this, second is 2n pi, and third is 2n pi by 3, of which the most general form I can see is x is equal to n pi by 3, as it contains all the solutions including the second one as well as the third one. So it's the most general solution, and general solution, as we know, is the set of solutions, all the solutions that are possible for the trigonometric equation. Let's proceed to the next type. The next type is solving equations by transforming a product of trigonometric functions into a sum. Now that's the reverse of type 3 that if we see. Earlier it was the transforming a sum into a product form, that is sin c plus sin d was converted in 2 sin c plus d by 2 and sin c minus d by 2. So two signs were in addition and they were converted into multiplication of two trigonometric ratios afterwards. Whereas if I see here, I have in multiplication 2 or 3 trigonometric ratios and I will be converting them in sum form. I will proceed with this. I have to find the number of solutions for the trigonometric equation in the region 0 to pi, that is in the first and second quadrant. So I will proceed with this. I have 4 sin x. Now sin 2x will be written as 3x minus x, and sin 4x can be written as 3x plus x. I will tell you why I have written it in this manner. Left hand side would be as it is, that would give me the right hand side as sin x sin square of 3x minus sin square of x. Because of the formula that we have, there is an identity that if sin of a plus b into sin of a minus b, that can be written as sin square a minus sin square b. So with this identity I have written sin square 3x minus sin square x. So next part, sin 3x is equal to 4 sin x sine square of 3x minus 4 sine cube x. On the left hand side, sine 3x can be written as 3 sine x minus 4 sine cube x. That's an identity for sine 3x is equal to 4 sine x sine square 3x minus 4 sine cube x. So 4 sine cube x would cancel out on both sides as it is an addition, and I'd be left with 3 sine x minus, if I transpose the right hand side, the residual term, that is 4 sine x sine square 3x on the left hand side. So the equation would then become 3 sine x minus 4 sine x sine square 3x, of which sine x would be taken common then, and I'd be left with 3 minus 4 sine square 3x is equal to 0. So the next thing I'll get is either sine of x is equal to 0 or sine square 3x is equal to 3 by 4, which in that case would be sine square 3x is equal to sine square of pi by 3. From the first equation I would get the solution as x is equal to n pi, and from the second I would get 3x being equal to 2n pi. I would get n pi plus minus pi by 3, as it is of the form of sine square theta is equal to sine square alpha, and the solution to that was theta is equal to n pi plus minus alpha. That's why I get this solution that can be rewritten as x is equal to n pi by 3 plus minus pi by 3. Now if I consider both of them, and at last I have to find the values for the solutions that would be lying in 0 to pi. Now if I check for first solution, the value n is equal to 0 only would be giving me a solution that is 0, and for 1 it would be giving me a pi. So I'll write down the two values. For second, if I say I'll have n pi by 3 plus minus pi by 9. So I'll have the values as, if I consider n is equal to 0, that would give me pi by 9. Then next I would get, if I consider it as 1, that shall give me pi by 3 plus minus pi by 9, pi by 3 plus pi by 9, which would be 4 pi by 9, and if I consider it a negative, I would have pi by 3 minus pi by 9, and I would get 2 pi by 9, and so on. So I'll have these solutions. Now let's have a fun fact. Tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 is equal to pi. Is it? Tan inverse of A plus tan inverse of B is equal to tan inverse of A plus B over 1 minus A into B. Please check for yourself whether it's true or not, and if it is, good luck then. So students, in this part we learned how to solve equations of the form involving the product of trigonometric equations by converting them into sum form, and involving trigonometric equations having the trigonometric ratios as sums into product form. In the next part I will be discussing the type where I have to substitute expression of trigonometric ratios as some variable. So stay tuned.